The first principle is just the limit definition of derivative. So we'll start by drawing a curve, assuming you are, because this is a curve. And remember, to find the derivative of any function is to find the rate of change of that function, meaning we need to, okay, let's draw our x and y. So this is my x-axis, this is my y-axis. So assuming a point here, the point is x. You know the point here will be f of x, that's y now. So our main aim is to find the gradient of a tangent line. That's the meaning of rate of change at that point. We need to find the gradient. So we draw a tangent line to that. So this is my tangent line. So this is my tangent line. So to find this slope of this tangent line, that's our target. But we can't just, from the definition, you know, the slope of a line, we need an extra point for you to find the slope of a line. So we now introduce another point on the curve. So let's the point be this. So we now introduce another such that it will pass through the same point as the tangent line. So the second line, this second line is called a secant line. The line that passes through 2 points, secant line. So the coordinate of this point is, let's call x plus the x. So our y value is now f of x plus the x. So our main aim is to find the slope of this line. I told you where the target then was to get the slope of a tangent line, but we introduce another point because we can't find the slope of a line with only one point. So we introduce the secant line. With that, we form a right angle triangle such that the change in y is now f of x plus the x minus fx. Y change in x, this minus this is the x. So the slope of the secant line now, m of secant line, is f of x plus the x minus fx over the x. But remember, what we want to find is the slope of the tangent line. So, but how do you make this second line to look like the tangent line? We now make this to approach the tangent line. We make our second line to approach this, and as it's approaching, you notice that the s is going down to 0. So this is closing up to this point. As it's going down, there will be a time it will coincide with this. So at that point, we say that the s is going down to 0. We now introduce what we call limits of a curve as it approaches a particular point. This is what we call the limit. And what do you notice? The s will always be going down to 0. It will be closing up. So this is now the slope of our tangent line, which is now the limit of the slope of the secant line, which is f of x plus the x minus fx over the x. So that's it. That's the derivative. That's the derivative of this function at a particular point. That's the slope of the tangent line. That's it. Limit of the x tends to 0 of fx plus the x minus fx over the x. So that's differentiation from the first principle. You see the example, we have to find the derivative of 3x squared plus 2x plus 1 from the first principle. Okay, the function is function x equals 3x squared plus 2x plus 1. You remember that our derivative, which is dy dx, is always f limit of dx tends to 0 of fx plus dx minus fx all over dx. So that's what you use here. So the next thing is to find fx plus dx, which is 3. Wherever you see x, call it x plus dx, x plus dx squared plus 2x plus dx plus 1. So which is 3. We expand this is x squared plus 2x dx plus dx squared plus 2. Okay, let's not open this now. Plus 1. So open up this. 3 times that is 3x squared plus 3 times 2x dx is 6x dx plus 3 dx all squared plus you open up this, which is 2x plus 2 dx plus 1. So remember, we've got an fx plus dx, so we need to subtract this from this. So we have fx plus dx minus fx is now this minus this. X squared minus that is gone. 2x minus 2x is gone. 1 minus, so we are left with only 6x dx plus 3 dx all squared plus 2 dx. So the next thing is to divide by dx. So over dx over dx. You know, we divide each of them by dx. So 6x dx over dx is 6x. This is, remember this, so remaining only 3 dx. Finally plus 2. So the next thing is to find the limit. Therefore, what we are looking for now, which is our dy dx. Dy dx is now limit of dx tends to 0 of 6x plus 3 dx plus 2. So which is 6x. Substitute plus 3 times 0 plus 2. The answer is 6x plus 2. So that's the answer. Let's solve another question. As to find the derivative of 1 over x from the first principle. Okay, we know that the first function, which is fx, is 1 over x, because our main aim is to find dy dx, which is limit of dx tends to 0 of fx plus dx minus fx over dx. So that's our main aim. So the next thing is to get our fx plus dx, meaning wherever you see x, call it x plus dx, which is 1 over x plus dx. So we've gotten this, so we'll subtract. So we'll have fx plus dx that's minus fx is now equal to 1 over x plus dx minus 1 over x. So LCM x times x plus dx, which is x minus x plus dx. So what we have x minus, so we are left with minus dx over x plus dx. So the next thing is to divide both sides by dx. As this by divided by dx. So we have f s plus dx minus fx over dx is now dividing, so we are left with minus 1 over x plus dx. So the next thing is now find the limit. Therefore, what we are looking for, dy over dx, is now the limit of the x tends to 0 of minus 1 over x plus dx. So we have minus 1 over, so substitute dx as 0, so we have x plus 0. What we have is minus 1 over x squared. So that's the derivation.